Well, good evening, everybody, and welcome. Thank you very much for joining us. As Lee's just said, this is my first time, so I'm quite nervous. I'm not a natural speaker or public speaker, but as he said, I've got a bit of experience, so hopefully we can, during the course of this online course, the 10 modules, we can delve a little bit deeper into the solar thing and so on. My name, as I said, is Richard Bailey. I'm going to switch my webcam on just for a very short period of time. I hope I'm doing this correctly, as this is my first time. And I think you might all be able to see me. That's me with the headset on. So just to show that I am good. I am actually a real person, not recorded or anything like that. I'm going to switch off now. See you later. Okay. So this is, I just want to make something clear that this is the first module of 10 in this series or in this course. So not everything here is going to be covered. Don't expect to get all the ins and outs of solar water heating in this first hour. This is an introduction into solar water heating. We look at a few things. What I'm hoping to give you in this first module, and for you to understand by the end of it, is just an understanding of the sun as an energy source, what it can do, what it, the power of it is. We will touch on other renewable energy sources as well, not heavily. Again, this is about solar, we do understand that, but we'll just have a look very briefly at some other sources. The pros and cons of solar, because believe me, it has got some negatives as well. The effect of using fossil fuels, and if you want to look at it in another way, it's the effect of not using alternative energy sources for water heating and power and all the rest. And then we'll have a look at the economics of solar. So what affects the payback period and so on and so forth. I'm going to try and rush through the first half of it because I'll let you in a secret. A couple of days ago, I had a little practice run with some peers of mine, and they all unanimously said that the waffle in the beginning, the details about the sun and that, is a little bit boring. Let's get to the solar. So I will try and do that. This is just an overview of what the rest of this course is going to be offering. We will delve into it as time goes by. This is just an introduction, but the second one is going to be the dynamics of water within a solar system. So what does water do? What can it do? What is it capable of? And what the dangers of it what are the dangers of it if it overheats? That sort of thing. Number 3 will be the components and tools that we use when we install solar. It might sound as if, why on earth are we looking at that? We all know the components. We all know the tools. That's true, but some don't know it. There are some components that, sometimes are a little bit misunderstood. So it's necessary to touch on that just to get a holistic picture. 4 and 5, I called it the engine room because that's about the solar collectors. This is where the heart of the system is. It's what makes things tick. It's divided into 2 because the first one we'll look at the 2 main types of solar collectors being evacuated tube as well as flat plate. The second part of that would be orientation and inclination and a whole bunch of other factors which affect the effectiveness, if you want to put it that way, or the efficiency of the solar collector. 6 is the different types of solar water heating systems. In other words, the different configurations, whether it's pumped or thermosiphon or close couple or split or whatever the case may be. 7 and 8 is the preparation before the installation. Now, again, this might seem to be reasonably unnecessary, but it's certainly not. Most solar installations that fail or that don't function properly, the planning phase was not done properly. It is at that phase that a lot of the critical steps have to be taken, and that's the phase where a lot of the critical steps, in fact, are not taken. 9 and 10 is we're going to look at the 10106. The standard for solar. We'll look at the actual installation of it, what's necessary, and what the deal is there. Also, at some point, I'm not sure when I'm going to slot it in, but I do want to put in a little FAQ, frequently asked questions. That's going to be driven by you guys, though. The FAQ, over the 3 or 4 weeks, we'll see what the common questions are, if there really a need to delve deeper into something. And then common failures. Being an auditor for PERB, we've come across common failures just through lack of understanding sometimes. So I'll sort of put together a list of that. Hopefully 10 or 15 minutes we can spend on that and just touch. It'll be interesting. My expectations.
Great.
Yes.
Richard, can I just quickly jump in there? Nothing wrong. I just wanted to just let the guys know that yes, there's a lot of, like you touched on, and say, well, why the introduction, guys, and all that stuff. We must remember that, guys, or this course can be counted as an accredited course. In other words, you can do if you do the whole 10 series and you haven't got, so if you haven't got your badge at the PRLB for a licensed plumber for solar, you can do this whole theory series as long as you complete the assessment at the end or during the stages and complete the final assessment and get your certificate. You can now use that certificate and go to the likes of a Watersmith or the likes of a Checker, and only have to do your practical side. You don't have to do the theory side. So it'll cut down on some costs for you on that specific side. So that's one of the reasons why we have to go through some of this waffle. Okay, I just thought I'd just add that in, Richard. Okay.
Yeah. Thanks very much, Lee. That is very important, actually, and I would have forgotten to say that, but thank you very much for that. Okay, so for this particular course, and you'll see the slide repeat itself at the beginning of each module. My expectations of you, I'm assuming that you know 10254, which is the geyser standard. It's the how to install geysers legally. I'm not going to tell you what a vacuum breaker is and so on and so forth here in this course. I'm assuming that you guys all know that. And then basic math skills, I'm not talking rocket science. Listen, I'm a plumber, so I mean, I haven't got real math skills myself, but I mean, we need to be able to add, subtract, and multiply, that sort of thing. And ability to listen is, and willingness to ask, that goes without saying. Obviously, this is going to be an audio intensive course, hopefully. I don't want to place too much emphasis on the screen. I prefer that you listen to my voice. And then please ask a lot of questions. There's no such thing as a stupid question, because it just doesn't exist. And then this picture was supposed to come in as a little bit of a after sort of an impact thing, but it says be passionate. Now I think it's photoshopped, but this guy is so desperate to get that picture. He doesn't care what's happening. He just wants to get that picture. So be a little bit like this guy. I want to introduce myself very quickly. I think we're probably going to run short, but as I said, Richard Bailey is my name. Did my apprenticeship in Kimberley. I'm not going to do this in subsequent modules. This is just an introduction. My practical and theory I did in Cape Town at Bifsa College and Athlone College, and I qualified in '94, and I've been PERB auditor for about 5 years. That picture is just to show you that I do actually get into roofs and I know what a roof looks like. Okay, what is solar water heating? Well, it's the principle of sun imparting some energy and heat into water. That's the basic principle of it. And it sounds easy, but there are a couple of things that one needs to take into account. The thing about the sun is that it's inconsistent. It's not something that shines from a fixed point in the sky all day, every day. It disappears behind clouds, it moves across the sky, the seasons change, and so on and so forth. So the technology that we use to harness the sun's energy has to adapt to that, and effectively what we need to do is make the best of a reasonably uncertain situation, and which we've honed that down the last however many years, 50 to 100 years. I think we've got some very, very smart solar water heating skills and solar energy skills, but we're gonna, obviously this is for the purposes of domestic solar water heating. So we all know the basics of it, but I'll ask you, if it's just sunshine that we're talking about that must shine on some pipes, what is the big deal, and why do we need standards? Why do we need controls? Why all the fuss? Because surely if you can take some pipes bolted onto a system as a pre-feeder, or make a homemade panel, put some pipes in there, and if it's working, if it's delivering you or supplementing your energy costs, then why should we go to the trouble of having the standards and controls in place? And that is why, because if if we're talking about DIY guys and it's your property, you're going to live and die there, you want to bolt on a homemade panel, that's fine. But this sort of installation here, I hope you can all see it, is quite rife. It's not something that I had to go and dig out of my archives for 5 years. It's in fact a client of mine that called me to her property for a different matter, unrelated matter. This was done by a qualified plumber. I failed to ask whether he had a solar qualification, but I doubt it. And it was done 3 years prior to me being there. It was on a second floor roof, and so it had been operating like this for 3 years. Now the important thing to know here, yes, we can all see the faults here. I mean, the roof, first of all, can't support it because it's not a trussed roof. The panel is facing south. The pipes are all plastic outside, no brackets, no routing. You can see there the guy took a tempering valve out and then he left that dead leg. It's ridiculous. There's no lagging. But the important thing to note here is that I'm going to call her Mrs. Jones. Didn't know, was none the wiser. Why? Because the geyser's backed up. So you've got your element in place with the thermostat and there was no timer installed. So the geyser is on constantly, acting as a normal geyser. The little bit of sunshine that panel might or might not get on odd days counts for absolutely zero. So for 3 years, these people were living with a system that was completely ineffective. They said to me they couldn't understand why there was no savings really that they could see. They weren't pedantic in that they went and looked at each bill and looked at each cent. But the fact is that this sort of thing happens. So this is what we're trying to prevent. If you're a DIY guy, you can more than welcome you experiment at your own home, have fun. But if you're a plumber and you're charging money for it, this is what we're going to try and prevent. Some facts about the sun. Now this is the waffle that my colleagues said I should get on with. It spits a lot of stuff at us. It spits a lot of power at us. 386 million gigawatts. There you can see it. I don't know how much that is. It's more than a light socket. 20 days of sunshine on Earth. In other words, 20 days of the sun's sunshine shining on Earth is equal to all the coal, oil, and gas reserves on the planet forever. Okay? 1 second of the sun's total output, not onto the Earth, but the sun's total output, is good for 500,000 years of our civilization's energy needs. That is a lot of energy. Okay, what are we interested in? We're interested in the infrared light, which is just to the right there of the visible spectrum. The visible spectrum is what we see. UV, which is shorter, most animals see, we can't. To the right of us, which the longer wavelengths, is the infrared rays, and that is what we pretty much are interested in from a solar heating, a water heating perspective. Very quickly. Okay, now this is where it starts to get a little bit more interesting. If you look at what the atmosphere receives from the sun per annum, the energy that it receives, this is per square meter per annum, 1,300 kilowatt hours per annum. The atmosphere, the top of the atmosphere receives. However, the surface of the Earth only receives 1,000 of that, so 300 of it gets lost. That tells us that the atmosphere has an effect on the intensity of the radiation, which is correct. It absorbs, it refracts, it reflects, and so on and so forth. So that it stands to reason then that the more atmosphere solar radiation needs to travel through, the less the intensity of it is going to be. So it has a great effect on geographical locations, which parts of the Earth are able to exploit solar and which parts are not. Most are, but there are places on Earth which it doesn't really make sense. Just as a way, by way of comparison, have a look at the difference between Europe and South Africa. Now, on average, as I say, the Earth's surface gets about 1,000 kilowatt hours per square meter per annum. Europe is about 100% of that average. In other words, that's the figure for Europe. It's about correct. South Africa, though, because of the latitude, we are much closer to the equator than Europe is, and the sun hits us at a much more acute angle than, is acute the right word? much more perpendicular angle than it does Europe. Europe is very oblique. It comes at an angle. So we are almost in places up to 2,000. In fact, I think the figure is about 1,950 kilowatt hours per square meter per annum. And that has got to do with two factors. Number one, the angle of interaction. I'll quickly explain that. Angle of interaction, reflection, and absorption of the atmosphere. You might say, well, that's the same thing, but it's not. Angle of interaction is if you hold a torch above a piece of paper, straight down, the light is circular. If you angle it, it's oblong, and the same amount of energy now has to cover a greater area, and that is angle of interaction. So no matter what the interference of the atmosphere is, the intensity of the light anyway is going to be less at an angle. The more the angle is, the less the intensity of the light. So that's one factor. The other factor, of course, is the increased amount of atmosphere that the light has to travel through to get to Europe. Because of the fact that it's hitting the atmosphere at an oblique angle, it needs to travel through more kilometers of it. Okay, that's a mouthful. Let's touch very quickly on other sources of renewable energy. Now, as I say, this is a solar course, and we're not really interested in the other sources of energy, but let's just have a look at them. Hydroelectric, it's been with us since, well, I don't know, since when. Think of a water wheel driving a millstone, for example. Think of a water wheel doing some or other kind of work. I'm sure the Egyptians had it thousands of years ago. Tidal and waves, that's also water related. There's huge power huge amount of kinetic energy in tidal movement through estuaries and river mouths. Wave power, that's constant, it's inexhaustible. It's just a matter of trying to harness the stuff. You know, you never quite know how to. I know that I've seen lots of machines that look as though they could do the trick, but the viability of them is another story. Biomass. Biomass is basically it is organic matter, which is of recent origin. In other words, it's not millions of years old like oil, coal, and gas. It's something that has been produced quite recently, i.e., animal waste. You know, I don't know. Wood is not a sustainable resource. You can't cut down rainforests to burn to run power stations. But so, just to touch on a point for this biomass, it is something that is renewable, but it is also something that can be exploited and used to such an extent as to make it non-replenishable and unsustainable, and that would then turn it into a non-renewable resource. So it needs to be managed quite carefully. Then geothermal, we don't use it too much in this country. It's very widely used in Northern Hemisphere, I believe. They use, instead of heat pumps, air source heat pumps like we do, a lot of their heat pumps run off ground source heat from, and they convert that heat into and put it impart it into the geyser. And then wind, I mean, that's one of the most, yes.
Yeah, just remember your opening slide. The guy's feet were on fire. There's a good example of geothermal.
Absolutely. And if you lived in Hawaii, I'm sure you wouldn't really need to drill too deeply to find it. I reckon it's right there.
100%.
Wind is very common. Where I am, Cape Town, there's a place just around the corner called Darling. They have a little wind farm there. It's not big, but it's there. And many countries in Europe are very, very heavily reliant on wind power. In fact, I think Denmark is one of the few countries, if not the only country, that can pretty much claim to be burning zero fossil fuels for their energy needs. I mean, that is incredible, and most of it comes from wind. So just quickly, the acid test for renewable energy is, the question is, does it naturally replenish itself? Will it naturally replenish? Not with man input or anything else. Will it naturally replenish? If the answer is yes, then it is a renewable resource. Let's look at the pros of solar energy. What is good about it? What can it do for us? Running costs when once it's up and running, It's the running costs are very low. But the proviso is that it's a properly designed and spec'd and installed system. If it's not that, then the running costs go out the window because maintenance overtakes the whole story. It must also be maintained, but if a properly installed system is in place, your running costs are very low. It needs only light, which means it doesn't need any other input in terms of cabling, in terms of batteries or anything. We're not talking about power, but you can put it in remote locations. You can put it in the middle of the desert where there's no other source of power, and you can have power. It can utilize the existing infrastructure such as buildings and rooftops. So in some cases, you don't even have to build massive infrastructure to install it. The pollution is limited. Not totally lacking, because there is a pollution factor in the manufacture of this stuff, as well as the getting rid of it. I mean, you've got to chuck it somewhere. So there is a pollution factor, but once it's up and running, there of course is no pollution, and of course it's quiet. There's no noise, so you can have it anywhere. It's not going to be a nuisance to anybody, which is a great thing. I mean, think of generators. Even heat pumps have a little drone sometimes which transmit. Anyway, I'm not here about heat pumps, Lee. I don't want to steal your thunder. Okay, the cons of solar energy. What are the drawbacks? Initial cost, it is quite pricey. On a domestic solar situation, you're probably looking at between 20 and 25 grand or something like that for a decent one, and more. And it depends on a moving energy source, and of course an unreliable energy source. It moves around. We touched on it earlier. You need to either track it, which is very, very expensive and unrealistic for a domestic situation, or you need to make the best of a reasonably difficult situation, as we said before. And then, of course, it needs daylight. We've just said in the previous slide that it needs only light. Well, the fact is it needs daylight. So it doesn't work at night. It doesn't work during cloud cover, etc. So there are periods where it becomes unreliable. So if you want it as a reliable, constant energy source for an installation, you actually can't have it. You've got to have some sort of a backup system. And of course, it's affected by weather as well. All right. We're going to move on now to the environmental benefits of using solar. So why, this is beyond what Mrs. Jones really thinks about. I know that there's increasing awareness these days of the negative effects of fossil fuels, etc., and the need for us all to start conserving and living green. I know there's a groundswell of that, but Mrs. Jones, at the end of the day, actually looks at rands and cents, and so this sort of thing is not what she would look at unless she is that way inclined. Air pollution is a big one. I mean, let's face it. Burning fossil fuels, you're introducing all kind of pollutants into the air, from benzene to mercury to hydrofluoric acid, and we're not even talking about the most common greenhouse gases like carbon dioxide and methane and those sorts of things. Acid rain is, contrary to popular belief, it's not rain that falls through an acidic atmosphere and when it lands it is slightly acidic. It's actually when aluminium is leached from the soil or from the ground and then carried to water sources, and it terribly affects fauna and flora. And one of the very first indicators that there's an acid rain area, affected area, is are amphibians, funnily enough, frogs and salamanders and things like that, fish as well, but especially frogs. Frogs are a very good indicator when an ecosystem is starting to take some strain. One of the overriding factors when it comes to pollution and when industry and the world as a whole talks about burning fossil fuels, I mean, the whole world revolves around it. So there's very little honesty when it comes to the big guys talking about it. I'm talking governments and those sorts of big guys. Is the suppressed disclosure of the effects of pollution is it's just sickening. It's immense. If we knew a quarter of what was actually going on, I think we would all change our ways immediately, and that that would negatively affect a whole bunch of big players in the world, and well, draw your own conclusions from that. The stuff that it can cause is also the health effects of pollution is crazy. All right, so let's just touch on the greenhouse effect quickly. This is what the planet is facing at the moment. We are in a drought at the moment in this country. You and I have all got water restrictions. It's as a direct result of the word escapes me now. There was that phenomenon, the climatic phenomenon that I can't remember the name, but by and large, El Nino, was it? El Nino, that's correct.
El Nino.
So, but by and large, we are experiencing the effects or side effects of greenhouse effect, and that is simply, as the word says, we all know it. It's the warming up of the earth due to heat being trapped by what we term greenhouse gases, and which act like the glass panes of an actual greenhouse. Now, without greenhouse gases, this earth would be about 30 degrees colder than it is now. So greenhouse gases are essential. They're not our enemy. They are absolutely essential. 30 degrees colder than we are now would be tantamount to a lifeless planet. You cannot live there. So greenhouse gases are absolutely essential, make no mistake, and that includes carbon dioxide and methane, etc. To give you an indication what we're talking about in temperature change for the greenhouse effect that we're facing currently, and make no mistake, chaps, we are in it. It is here. And forgive me, this is not why I'm here. We're talking about solar, I know, but let me just finish this point. The last ice age, that was 20,000 years ago. The general temperature there was about 5 degrees colder than currently. It took 20,000 years. That was an ice age, not a cold spell, not a bad winter. That's an ice age. It took 20,000 years for the temperature to lift from where it was then to where it is now. On average, the average temperature of the Earth, 5 degrees. 20,000 years, and that's fine because life has got the time to adapt, and we all adapt, and we pitched up in that time period as well. But we are now going to force the Earth to experience another 5-degree rise in temperature in 100 years. I'll leave you with that thought. Okay, so what are the effects of global warming? Very quickly, changing water resources. The availability of water geographically is going to change. He who has it now might not have it tomorrow, and he who has not got it today might have it tomorrow, etc. So that's going to create a lot of conflict, and wars are going to be fought about water. Oceans are going to rise. Cyclones are going to be more frequent and more intense. Agriculture is going to be affected due to increased and more intense droughts and flooding. Health will be affected both directly and indirectly. You can think about directly related health issues and even deaths from temperature-related health or temperature-related deaths like heat waves and intense cold. People die on the street from cold, from exposure. And likewise, the old and the infirm sometimes pass away because of a heat wave. It's happened. The natural environment is also going to change dramatically. We're talking about rainforests, perhaps, and I'm speculating, but rainforests that might not be able to be sustained by the rainfall in future because the rainfall patterns have changed so much. So the whole fabric of this planet is about to change, and I mean we are sitting on the brink of it. Anyway, the weather itself is going to become much more extreme. Much more frequent events. That you're gonna have weather refugees. You're gonna have displacements of whole populations, and it's quite a scary thought. I think a lot of us like to be, myself included. We live our lives and we go to work every day, and we somewhat have half of our heads buried in the sand, with only a quarter of an eyeball sticking out and actually taking notice of what's happening around us. But I mean, the thing is that, guys, that we can actually make a change. We cannot change the world, but we certainly can change what we are able to, and that is installing decent, properly functioning solar systems. The more of those that get installed, the better the reputation of us as a trade is, the better the reputation of solar as a technology is. It can start a groundswell. Don't doubt that. Lee, I think it's time for a poll. I think we've missed the first poll, but that doesn't matter. Can we just do the second one now?
Is
if
that
that's
the
okay?
economic considerations for solar
Yes.
water heating systems? Okay, great.
Yes. Yeah.
Okay, there you go. It's coming up, so you can take it away there.
Okay.
On your side.
Should,
It's coming up.
am I talking
Yeah,
to it?
Yeah, it's fine. You can talk to it. It's fine.
Okay. Okay. Is it up?
Yeah, it's just feeding through at this particular point in time. So, let me just take it from here. So, okay, the poll is the economic considerations for solar water heating systems are not really something I consider often, good to look at, but often overlooked, and good to look at, or is it vital? I'll repeat that again. So, the economic considerations for solar water heating systems are not really something I consider often, or is it good to look at but often overlooked, or is it vital? So guys, just stick your vote in there, what you think is the best one. There we go. Got 50% people voting. So far, 75. It's good. Great, I'll just give it a couple of more seconds. Great, there we go. Okay, I'm going to share it quickly. Hey, Richard, can you pick it up on that side?
I actually can't, Lee. I must be honest. I will.
Okay, right. So everybody said it was vital.
Yeah. Okay. Excellent.
Audience is vital. Okay.
Then let's pack up and go home because I'm done.
Yes.
No. All right. So let's move on then to the economics of solar water heating, because this is the crux of the matter. I mean, this is why Mrs. Jones puts solar geysers in and spends 20 grand on a solar geyser. This little graph in front of you shows an average power usage for a household with solar and a household without solar. It's drastically different. You can have a look at the figures there. I don't know this off by heart, so let's have a look. We're talking about it starts off with 2 people. Even at 2 people, you have a saving of almost double, or should we say half. Half of your energy bills are saved if you have a properly installed, I must stress it, it's going to have to be properly installed and efficiently installed and properly sized, etc., solar system. You're already saving half your energy bills with 2 people, and that climbs quite a lot percentage-wise the more people are in the house. You'll see that the energy expenditure for a solar, whether it's for 2, 3, 4, or 5 people, generally speaking, it doesn't differ much. The energy expenditure hovers around 2 kilowatt, 2,000 kilowatt hours, I beg your pardon. And for non-solar heating, that line is as straight as an arrow. It just goes up. It stands to reason. The more hot water you need, it's directly related to the amount of electrical input you need to input into the system. So it just shoots straight up like an arrow. So that is a very simple but effective way of illustrating exactly how much of a savings a properly installed solar system can actually produce. Look, for it to save you any money, it must first pay for itself, and then it will start paying you back. So it must start off by paying for its cost, its initial cost, and after that you will then look at oh well, I'm saving $100 a month or $300 a month or whatever the case may be. South Africa, just as an interesting note, has they have set targets for energy efficiency improvement. It's a 20-year thing. Well, there's many goalposts, and I don't know them all, but there's a 20-year goalpost of saving over 4,000 megawatts of power in 20 years. In other words, cut down usage, demand for usage by 4,000 megawatts. What determines which factors need to be considered in order to achieve a graph like this, in order to achieve those sorts of savings? What do we need to look at, and what are the factors that affect it? Let's have a look. So firstly, and it's the crux of the matter, is how much booster input is required. That is, I mean, that's it right there. How much time is your element going to have to spend on, as opposed to off? And that's some factors which now influence that is the collector positioning, the quality, I beg your pardon, the quantity and temperature of the water that's required, the size and efficiency of the collectors and tank. That's critical, because we'll see later in this series that sizing plays such a big role in making a system efficient. And in fact, I'm not going to get into it now because that's for another time. Climatic conditions. So if you're living in an area that is 50% cloud cover, 50% of the time, it's going to impact the availability and the workings of it. Timing setup. That's critical, because like that very first or second slide that I showed you of that installation, yes, that panel was there. Even if that panel was properly positioned and everything, I want to tell you that their savings would be very, very minimal, because there was absolutely no timer on there. And then management of the system. Mrs. Jones needs to know exactly how to manage the system. She needs to know how it works. She needs to know the principles of it. She needs to know what the objectives are from a technical point of view. Don't confuse her, but she needs to know what the objectives are in trying to save money with solar. She can't just, it's not a plug and play. They've got to play ball. There's lifestyle changes that come into it, etc. By the way, booster power needn't only be electrical, but it can be any other sort of booster input into that solar system, for example, gas or heat pump. The next factor which affects the payback period and the effectiveness of the thing is the lifespan of the system. I mean, if the thing's going to last 5 years, it will hardly have paid itself back, if it did at all, and then it's going to do it, and then you must now go and spend another 25 grand. So that's not very smart. So what affects the lifespan of the system is the construction and the quality of materials. So if you use bad quality materials, they're not going to last. Water quality has an effect as well, although there are measures that that you can take to negate that somewhat. The temperatures that this thing is going to be experiencing, if it's overheating regularly, you're placing big strain on the system. That again falls into the design side of things, the sizing, etc. Pressures, although we generally all installations will be regulated. The pressure will be regulated, but yeah, it does play a role. I mean, if the thing is going to be subjected to adverse pressure conditions, it does play a role. Quality of the installation, there's a biggie. Look to the left. There we are. It's the same installation from a different angle. That it's not going to pay for itself. And then maintenance. You got to. Mrs. Jones has got to realize that she has to maintain her system, and that means once a year. That plumber must come and check it up, check the lagging, see that it's all properly painted and protected still, etc. The next factor is the total available sunlight. How much sunlight is being delivered into your geographic location, and not only to your geographic location generally, but your specific location. In other words, is there shading? Is there a big tree nearby? So, okay, well, let's start at the top. Latitude, that is your geographic location, but we've already established that in South Africa, we're golden. I mean, we needn't worry about latitude too much. Inclination or orientation, that's which way your panel faces. And so if you're going to face it south, like that other one, you're in a hiding to nothing. Local climate, Cape Town has rainy winters, so Cape Town solar efficiencies drop dramatically. Having said that, they're still effective, and we do have sunny days, and even with semi-cloudy days, there are some systems that are effective. And then shading and dirt. Shading is a big thing, and we'll touch on that in more detail a little bit later, so I'm not going to go into it too deeply now. Next thing is efficiency. How efficient is the system? Now check this out on the right. I mean, you know, as efficiency goes, that's pretty sweet, because he hasn't spent more than 35 cents on turning 2 taps into a mixer. Now, I've been a plumber for 30 years, and I want to tell you, I cannot do that. I cannot be that efficient. So this oak has got something to teach us all. That's a joke, by the way. All right, so what is the efficiency of the system? What are the factors that will influence that? With the type of glass of the collector, it does make a difference. We're talking about flat plate collectors. Some glass has high reflective properties and low retentive properties once the heat is inside the collector. So, and other better quality glass covers have the opposite. So they retain heat better, they collect heat better, and they retain it better. The retention of the ability of the collector to retain heat, in fact, of the system, not only the collector, but how well does it retain the heat that you and Mrs. Jones has spent so much money on, and you as a plumber has spent so much time and effort on trying to gain. How well is it retaining that heat? That is at every point in the system. That means the collector needs to be properly insulated, because the collector can lose a lot of heat downwards into the roof surface if it's that way installed. So it needs to be a good quality collector with good quality insulation in that box. It needs to be well lagged. When you know, you say to yourself, oh well, when water flows, you know, a lot of the heat, I mean, how much heat loss really is there? When you open a tap, none of my pipes in my ceiling are lagged. I open a tap and yet the water comes out hot anyway. I mean, the heat loss is so minimal as to be. But we're not talking about flowing water necessarily. It's the stagnation of the system. When the system sits and does nothing overnight, that's when you lose all your heat. So how well can the system retain the heat that it's worked so hard to gather? Your timing setup is crucial, because if you're just going to put the timer on to suit your habits, let me explain. If Mrs. Jones says, no, man, I'm adamant, I will shower, 6 of us are going to shower in the morning. And so you will put the timer on for 4:30 in the morning or 3:30 in the morning, and you will provide me with hot water because the solar can't give it to me. Well, then you might as well not use the solar, because if that's the attitude and if that's the criteria and the need of the homeowner, then it's not really going to work. So timing setup, you've got to make sure that your input from your alternative power source, your backup power, is minimal and at the right times only. Ingress of moisture, it goes without saying. The collector especially must be waterproof. You can't have a damp or a wet collector absorber plate underneath the glass. Even though there's no wind chill factor, it still radiates and expels heat. So I mean, that speaks for itself. Ingress of moisture is also one. Other factors are hot water usage patterns. So we've touched on that. How do they need to use hot water? If as I said, I mean, 6 in the morning, it's not going to. Government rebates, that's fallen away. For all intents and purposes, it's not really relevant to us anymore, but it could be again in the future. And then tariff structures. Also, from where I live, we don't have tariff structures that differ. But I'm not sure about the rest of the country. There might be areas where you've got peak times and you pay a little bit more for electricity during certain hours and so on. So if that's the case, then you would obviously want to set the timing of the booster setup to take advantage of that and try and set the timing to off-peak periods. Okay, Lee, I must be honest, I haven't really been looking at timing and so on. I probably got about 5 to 10 minutes left. Are we on track? What is the time now? It's about 20. 5
Yes,
past.
we are
Yeah.
on perfect timing. We're running fine at this particular point. We've got about 10 minutes left. So keep going.
Okay.
I think the guys
Okay,
are doing
cool.
great. Great, thanks.
Okay, cool. This is a simple calculation, payback calculation. It's just to illustrate what. Sorry, I beg your pardon. It's just to illustrate what can be expected to. What can reasonably be expected, realistically be expected to be saved from a solar installation? I mean, and if it's properly installed. Let's quickly run through it. So I took figures which are not close, but reasonably, I think, standard. Monthly consumption of a household, let's say it's 1,000 kilowatts. Of that, about 45% to 50% of it could be attributed to your normal geyser setup with your element arrangement. So 450 kilowatts of the 1,000 kilowatts is for geyser. Current cost per kilowatt of electrical energy, 136 roughly. So if you convert to solar, you can reasonably expect to save about half of your electrical costs, water heating costs. So that would then translate into about half of 450 kilowatt hours is 225 kilowatt hours. So, and by the way, you'll see that little star thing there, that is quite conservative. If it's a properly installed and sized system, it can be considerably more than that. Let's say it costs 20 grand to install. And let's deduct from that the cost of a normal geyser, because now we're offsetting one against the other, because the choice is either solar or geyser. So we've chosen solar. So we have to say, look, a solar costs 20, geyser costs 9. What's the difference? How much more is a solar going to cost me? 11. So 11,000 rand is the figure that you need to save. It needs to pay itself back. At 136 for 225 kilowatts, that's 300 odd rand per month. And so if you extrapolate that into a time period, it's about 3 years. And that's realistic. That's not actually trying to be clever and funny like Volkswagen was when they told us about their emissions values. That's being realistic. So 3 years, if the system is properly installed, it can pay itself back in 3 years. And then by the 4th and 5th and 10th year, you're paying yourself a nice little, go on a holiday or something like that. So that is something that you can, a very quick and easy calculation you can show to Mrs. Jones and explain to her that 3 years, you'll pay it back. That is actually pretty much it. I'm going to just go to this slide here in conclusion to recap really what we've looked at, the pros and cons of solar, and a good critical factor to remember is that solar isn't always the answer to everybody's stories. It's an extremely efficient and good technology to harness, but there are some situations where you need to look at another technology. And this, again, guys, all falls into the preparation before installation. It all falls into a thing called a water audit, which we'll touch on later. And yeah, so that's that. And then just know how powerful that sun is. It really is. It can do some serious good, but it can do some serious harm. And then to drive home again the benefits of the solar in terms of the economical side of it, the rands and cents. The benefits of it are real. Unfortunately, in this country, in the last 10 or 15 years or whatever the case may be, we've had thousands of solar installations being put in place, and unfortunately very few of them actually work, if any. There might be 1 or 2 or 5% of them work to their full potential. Some are very much better than others are not so good, but very few of them work to their full potential. And a big fall down, apart from the obvious rubbish that we saw in 2 of those pictures from that installation, apart from big fall down often is sizing. And we'll look at how important sizing is a little bit later. Okay, guys, well, thank you very, very much for joining me. I have got 1 or 2 extra slides just to show you, which is what you can expect from the next session. This is going to be, as I said earlier, it's going to be the dynamics of water within a solar system. So what does water do? What can it do? What's it capable of? So we look at thermal expansion, overheating systems, why they overheat and what can happen if they do. The thermosiphon effect and reverse thermosiphon effect for that matter, and then stratification, which is also a very important thing in the efficiency of a system. And with that, chaps, I say thank you very much. I hope you've enjoyed it. I hope I haven't bored you too much. This is really one that is not going to be, it's not going to be the most interesting module of the lot. When we start getting into the technical stuff, I certainly am looking very much forward to that. Because it's what I know, it's what I do. I'm not a scientist, so I wouldn't be able to tell you the sun's power unless I have it on a slide in front of me, which luckily I did. So, chaps, thank you very much. And Lee, I believe I'm going to hand it back to you if that's how it works.
That's 100% correct. Thank you, Richard. You know what? I think you did very well. I mean, just for your first time. I mean, what do you think, guys? I think you did brilliantly. I think you paid for his way. But thanks a lot, Richard. I think the truthfully, there's no questions and any questions out at this one, the guys here. I think you basically, answered most of them, but I think we'll get into the technical side. This is kind of like the real boring side. Stuart says, well done, great stuff. Thank you. Yes, guys, and with that, thank you very much for joining us. We will, there is a little survey afterwards as usual, where you can rate Richard, and then just add a few comments there as well. But anyway, thank you very much, guys. Please join us on the next webinar session for solar. That's next week. And as I said to you, this is a 10 series, which you guys can, if you collect that whole 10 series, you can use it against, you can use it for your theory component if you're going for that licensed plumber badge at the PRRB, or the right to sign off the COCs. Great, thank you very much, and highly appreciate it. Enjoy the rest of your evening, guys. Thank you. Thank you very much, Richard.
Thank you.
Good. Okay. Ciao, guys. Bye.